Good afternoon, everyone. We are live. We're here at the Science Club Annex, as I like to call it. There we go. I just want to get my monitor situation up. Hey. There we go. All right. I'm situated the way I want to be. So, I'm going to turn. And like I said, I'm monitoring myself so I can see. So, welcome to Saturday Science with Miss Steph. And let's double check. We're a little early today, but yeah, sometimes you're a little early. I just want to give everybody a little bit of time to come on to join us. See if I can invite some friends to join me. Right. Like I said, we're a little early, but that's fine. Just inviting a couple people. Okay. Ladies and gentlemen, we are live. So, hi! Thank you for joining me for Saturday Science with Miss Steph. It is a busy Saturday out on the Harlem streets for various reasons, but we're going to do what we normally do, which is our Saturday Science fun activity. So, today, as usual, you know how we do. We've got two activities that I'm going to walk you through. We've got a chemistry-based activity here where we are going to use our theme and what has been our theme ingredient for the majority of May. And yes, next month I'll switch over to a little something else. But this has been our theme ingredient for the majority of May. Our rapid rise yeast. Believe it or not, you can do quite a bit of science with that. And I'm going to discuss with you some of the activities that you can do with Smart Circuits kits. Yes, so once again, thank you for joining me for Saturday Science with Miss Steph. I am Miss Steph, and I am the founder and executive director of Triple F Empowerment Inc. We operate the fun and exciting Miss Steph Science Club. We have several different activities and services that are available to you. In particular, we are not only raising funds for, but also taking registration forms for Summer Science Club. And Summer Science Club this year is going to be virtual. I'll come to you in this manner. And also with Summer Science Club, children are going to get their own personal materials kits that will be provided to them. They'll get several t-shirts. They're also going to get safety glasses and lab coats, and they'll get some one-on-one time with me. So that's pretty much it for what we've got going on these days. We do have several of their classes and so forth that you can check out and learn more about at our website. Once again, it's Miss Steph, and thanks for joining me. I'm going to launch right into this here, all of this. So our first activity, as I said, is going to be based on using yeast, rapid rise yeast. Now, last week, if you may recall, we delved into some alternatives to the ever famous and popular and old school science activity known as elephant toothpaste. And typically with elephant toothpaste, you need two main things. You need hydrogen peroxide in some form, and you need yeast. So we've got our yeast, but you might be thinking to yourself, Miss Steph, where is the hydrogen peroxide? Where is that? Okay. Yay. Oh, hi, Melanie. Love seeing you. This particular product is going to provide the hydrogen peroxide for us today. And yes, you may be thinking to yourself, Miss Steph, that looks like conditioner. It looks like conditioner because It kind of is. All right, so this is Cream Peroxide Developer. And for all of my beauty heads out there, yes, developer as in hair color developer situation. But guess what? The main ingredient is in this, right? Doesn't it say right on here? Is peroxide. So we're going to try it and see the differences, right? And kind of see what happens. So I like to do 3 samples, as you all know. So let's set up our 3 samples for today. I'm going to use these nice, cute little medicine measuring cups. Okay. I am going to take my rapid rise yeast, which even in these times is relatively easy to obtain. Okay. And I'm going to open it up, and I'm going to I'll make one set where the rapid rise yeast is actually going to be, hi Jean, is going to be in liquid form. So I want to do this. I'm going to actually turn this into a solution. So I'm going to take a whole packet so that we get a pretty high concentration of our yeast, a whole packet of that. And then I'm going to add 125 milliliters of water. Okay? So just for a quick reminder to make sure that everybody understands where we're at and what we're doing today. Today we are using hair developer, 30 volume developer as a peroxide replacement, and just observing to find out whether or not we'll still get the same effect that we would using your over-the-counter liquid hydrogen peroxide that I used last week for our elephant toothpaste reactions. Once again, we've had yeast. Okay, we've had yeast is our theme. Hi. We've had yeast as our theme ingredient for our chemistry activity over the last couple of weeks. And I am stirring this up. Now, you may recall last week we actually used our yeast in dry form, and we added it in different at different stages. Today we'll use dry for one of the samples, and we're going to use our wet, our yeast that's in our 125 milliliters of water for another sample. And then for our third sample, I'll just do a straight control and show you what it's like to have the developer and the food coloring. All right. So as you know, I reach back here for my marker because any scientist worth their salt labels their samples. Alrighty then, so I'm going to do dry. This is dry yeast. So I've got my dry, wet, and then we're doing a control that will only have the developer inside of it. Should you do this at home by yourself without adult supervision? No, absolutely not. Please make sure that you have an adult, with you when you are doing this particular activity, because we're using this chemical here, the hair developer, which all of my fabulous folks that are into hairstyles and so forth are very familiar with. Okay, so what I'm actually going to do is put everything in the same order. Okay, remember last week we changed up the order to see if that would have an effect on our results. This week we don't want to change that because we're changing all kinds of other stuff, right? When we're doing an activity, when we're doing science, and if we're trying to make it as close to a controlled experiment as possible, we only change one thing, ideally. That's a controlled experiment, okay? But you know, we've got more than just one thing popping off here today. Okay, so for fun, I will be using my favorite color. Today, I'm using gel food coloring for my pigmentation today. And shout out for my folks, to all of my folks who are not only on right now, thank you so much, but are sharing this on their own pages so that all the children they know and the families that they are associated with get an opportunity to learn science today. Hello, it's free. It's here for you. Okay? Yes, so that was purple food coloring. And the next thing that I'm going to add is my developer. This, you know, I'm in Harlem, guys, right? So most of you are aware of that. I got this from the beauty supply shop that was previously open close to my home, and kept it, you know, because cabinets, we all know that there's lots of different materials in the cabinets. Okay, and so that's where I obtained this from. Truth be told, I'm not sure where else you would get it these days. I know, you know, some places there's Sally's open and so forth, and that's where I would get it if I were you, if you can't get to the other beauty supply stores. Okay, so I'm looking, there's a measurement place on here. I'm actually going to go to 15 cc's. Notice I'm moving this away from me because I do not want this in my eye. Okay? It's developer. No, I don't want that in my eye. Okay? I do have glasses on, so I have some safety precaution happening, right? My eyes are covered, and I am keeping a distance between myself and the chemical, trying to make sure I'm being responsible and showing you all how to be responsible, right? So, in our 3 cups that we have, around materials, in our 3 cups, we've labeled our cups as far as the way that we'll be adding the yeast to them. And then I put in 1 drop of the gel food coloring. You'll notice that that makes a difference as far as how the food coloring is going to interact with the chemicals that I have. Gel food coloring inside of each cup, and 1 cup is going to have dry yeast added to it. Another cup is going to have the wet yeast, the yeast that is here and that I'm blooming just here for a moment. And obviously this is a lot. This is more than I would need for this particular set of activities, but you could use it if you wanted to try it at home, again, with adult supervision in a larger container, right? You would need this much yeast. And then here we have our control. I'm not going to add yeast to this sample so that you can really truly see the difference. Okay? We want to get an opportunity to compare. That's what we're doing in science the majority of the time. We're comparing, we're looking at different samples and noticing the differences, and that's one of the ways that we're learning in science as far as how things react. All right, I'm gonna put my gel food coloring to the side for a momentito. Grab this back. Okay, I also am going to give this a quick stir. And some of you may be able to tell me in the comments why I'm stirring this, right? If you're looking at it, this is what it, okay. Because they all have the same 2 things in them, I'm not going to use like a different stick for each cup because they're the same thing. Same chemicals right now. Same chemicals, same concentration, all that right now at this point. Giving it a nice little stir. Once again, thank you for joining me today for Saturday Science with Miss Steph. We meet right here on Facebook live every Saturday at 2:30 p.m. Eastern Standard Time. And I take fun, different materials from my cabinets, from my science teacher cabinets. And I'm going to put that to the side so that it's out of the way and I don't. Okay, I use my different materials from my science teacher cabinets and I come and I show you some science fun. That's what we do right here every Saturday. So please, 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 I encourage you and invite you to come every Saturday. Okay? So now, there's quite a bit of yeast in here, right? So because of that, I'm not going to put, the whole thing in there. Just some of it. We're okay on our internet. Uh-oh. Don't have internet. But you all on my phone should be able to still see me, so it's fine. Okay. So I'm going to add the yeast, the dry yeast, as you recall there. So the dry yeast is now making contact with our peroxide concoction, right? So this is here like this. Now, the next thing that I'm going to do, as promised, I'm going to add my liquid yeast mixture to my my wet, right? This is labeled wet, and this was my dry yeast. And then here, nothing additional is going in there, right? Weird. So before I add this, I want you to predict. I want you to think about what makes sense here in this situation as far as how the yeast is, right? We've got this thick, you saw it was this thick cream texture that I added to the cup. So do you think that is going to be easier for the dry yeast to react or this wet yeast to react? Take a moment and think about that. Should it be easier for the dry yeast to react and mix in and so forth with our peroxide that's inside of the developer? Because that's not even the main ingredient. It's several things in there, right? Okay? Will it be easier for the dry or the wet to do that? I'm going to stir and I'll add. I'm going to fill it up a little bit and then let it sit. Okay? Once again, today we are switching things up a little bit. Normally, for this particular experiment, I would use the peroxide that you see in the brown bottle, right? That's what I used last week. But today, I'm using peroxide in a different form and showing you how you can switch experiments up a little bit. And yeah, okay. So let's put this a bit closer to you. Okay. So we have this here that looks like it's basically not reacting at all. And then we have this one that I don't know if you can tell, but I'm seeing bubbles here, right? This one is giving me some bubbles. Okay? And then here, nothing's happening, which, I mean, you tell me, does that make sense that nothing's happening in the control, the one that doesn't have any yeast? And, I would say yeah, right? Okay, so I'm going to actually put this to the side for a bit. And we'll come back to it. We'll let that sit and let it develop. I know, cheesy science teacher pun. Okay, now I've let you look at it through all the different angles. Okay, I'm going to go ahead and put this to the side, and then we'll move on to our electricity activity and come back to that at the end of class, or rather at the end of our session, right? And we'll do what we call our final observations and make our final conclusions based on what we see at the end of class after it's had an opportunity to sit for a little bit, to sit for about 10 minutes. Okay, so let's put this down, put this to the side as well. So now let's take out our smart circuits. Haven't used anything with, haven't done an electricity activity in a little while. And to be honest, sometimes I try to do everything things that you'll be able to do at home, but I also want you to see and get a chance to learn about all different kinds of science. So sometimes it might not be something that you could do it at home, but something that will still interest you and will still be fun to kind of watch for a little bit. All right, so let's take my kit out. We've got smart circuits, and this kit, this puppy, as you see, has a bunch of different pieces to it. And the key to working with this is, one, make sure that you are aware of what is inside of here and to make sure that you're keeping track of these pieces. By the way, if you wanted to get one, these are offered on Amazon for a reasonable price. So once you do get it, you want to, like, if you do decide to get it, you want to make sure that you keep track of all of your pieces. Okay, I'm going to take these out for just a second. I typically wouldn't do this way, but I need to lift something up from the bottom. Okay, so for today, we're just going to do a very quick little something. Okay, and on the box, it says ages 8 and up, but frankly, if you're a science club student, I know that you can do this at, as young as 5. I have students that as young as 5 have worked with this and have had great success. So once again, we're transitioning to learning about electricity, and we're going to use the Smart Circuits kit for that. All right. So this has I may or may not have the top anymore. These are interesting little kits. All right, okay, so we've got table of contents, and we have 50 different projects that you can do with the materials that are in there. And if you need additional materials, the instruction manual tells you. Okay, but we're just going to do not the very first project, but we are going to do this project. Make it 2. All right, so what's really fun about this is that, one, you get to interact directly with the wires, right? You get to use the wires, okay? And you get to connect the wires instead of like little bits. You connect it with magnets, and so you're not necessarily getting a chance to really notice the importance of the wires and complete circuits and so forth. But this activity, we are making complete circuits. We're using the wires, following instructions. It's gonna be awesome. All right. So the first thing that we need to do, we need 2 of these pieces. I'm following both the picture and the words, right? Because I know how important it is to follow instructions. And I'm going to put, see this here, right? I'm going to put that inside of here. Click. Now I know my Maloney's and my another scientist that is possibly watching, right? They know how to use this, right, guys? Give me a thumbs up if you remember how to use these. Okay? And so I'm going to take out what I need. It's telling me I need these gray, it might be a little hard to see. This is a gray wire. This is a white wire. It's telling me I need the gray wires. Okay? And I need to use the battery. Electricity is directional. Electricity, okay, runs from negative to positive, back to negative, okay, if it's in loop. And so this side says battery negative and this side says battery positive. So I have to make sure that I'm putting my wires in the correct place so that my circuit will function properly. All right? So I'm just adding this. While I do this, I want to encourage you all to put in the comments any questions that you might have for me or any particular requests that you have for future activities. Remember, you can put in your request and you can let me know what you would like me to do or what you would like me to try during the next Saturday Science with Miss Steph. Oh, uh-oh. Did something turn on already? What? I love it. So we already got one of the lights to turn on. At the end of this project, we'll have all 7 lights on if I follow the procedure properly. Okay? So I'm going to connect, tells me to connect this 1 to 2, right? And then another light came on, and now it wants me to connect 2 to, you guessed it, 3. Let's see if I do it properly. Oh, and another light came on. Now I need to do 3 to 4. And I'm doing 4 to 5. I'm doing these all in order, 4 to 5. Thank you all so much for staying on and watching and engaging in this fun science adventure. And then I've got 5 to 6. And I have successfully completed my circuit. As you see there, we have all of our lights lit up, okay? And this particular kit is so fun because you get to connect different things and you have lots of fun. And we, over the years, have used the smart circuits for various electricity activities. But just before I leave this, just a quick reminder of what electricity is. Electricity is a form of energy, and it is used by various pieces of equipment that we use on a daily basis. And it's called the flow of electrons. That's the basic definition of electricity. The flow of electrons. So electrons are flowing in here, and we know that our circuit is complete by the fact that our circuit turned on. We're seeing the lights turn on. And a complete circuit is a circuit in which all of the pieces of the circuit are getting electricity. So when you turn your phone on and it comes all the way on, that means that all the pieces in your phone are getting electricity. Okay? Yes, phones use batteries, but those batteries are converting the chemical energy into electrical energy. All right, my dears, that's it for this. And I'm going to dismantle it in an appropriate way and make sure that I put my pieces right back together. Once again, that was our smart circuit kit. And as you can see, there are several other things that you can do with this kit. And electricity is really fun to use and to learn and to explore. And the Smart Circuits kit is one of the things that we get to use during Summer Science Club. Everyone gets to touch the Smart Circuits kit. All right, so I'm kind of doing this quickly, but you notice I'm not just wrenching it. I'm, being firm, but I'm dismantling it in a way that will let me use these pieces at a later date. Uh-oh. Having a little trouble with this one. Okay. Now, take wires out. And once we put this kit away, we will be taking our final observations, right? Final observations of what? Who remembers? Can anyone tell me? What are we doing our final observations of? There's something that we did at the start of the video. Okay, putting this away neatly so that I know that I have all of my pieces. Right? Put my wires in their correct places and seam. And that's where our smart circuits. Once again, I actually use this kit with children of various ages. You don't have to be 8 at Science Club to use that kit, because all of our kids are smart. All right, so now, who's ready? Doesn't this look interesting? And so different from what it looked like when we put the chemicals inside of the container in the first place. Also, there's another chemical that we normally use when we do True Elephant toothpaste. True Elephant toothpaste has one more chemical in it. Does anyone remember? Do you remember the additional chemical that we normally put in True Elephant toothpaste that changes surface tension, that helps us wash off things that have oil layers? Anybody? Remember, soap, right? Normally we would have put soap. If we were truly trying to make elephant toothpaste, we would have added soap so that the foam would be captured and would develop in a different way. But you see that it's really has changed quite a bit, right? You have your dry. We've got our dry, and from here I can tell that there's some bubbles actually happening a little bit around the edges with the dry yeast, but with that yeast that was mixed in with the water, we are getting some like awesome, really cool and an exciting, thank you so much for joining us, and an exciting reaction happening. And I'm looking at now, it's actually still kind of like popping up. And then of course our control, nothing happened, because it's our control and we only have food coloring and our developer in it. And truth be told, I was kind of curious if it would change the color of the food coloring just a little bit. And not so much, right? Not so much. So let's kind of check our time. Oh, that's perfect time. All right, so thank you so much for hanging out with me and taking the opportunity to learn. Thank you so much for those of you who shared the live stream with your friends, family, and associates. Please keep in mind that you are more than welcome to do that in the future. We definitely encourage that. And we are, like I said, raising funds and taking registration for Summer Science Club 2020. That's still happening. I know that we're doing all these things virtually and all that, but Summer Science Club 2020 is still happening, and our students actually will be provided with their own lab in a box. And thank you Yes, once again, thank you for watching. I know I've said that a bunch of times, but it's really important to say thank you. Thank you for watching, and I look forward to seeing you next week, same time, same channel.